Unit 6, here we are. Expressions, equations, and inequalities. We are starting off the unit with talking about expressions, what they are and how to work with them. Lesson 1, we are learning how to combine like terms and how to evaluate or evaluating an expression. Our essential question for the lesson today is how are math terms separated? So let's look at parts of an expression. In an expression, we have what's called terms. These terms are separated by addition signs and subtraction signs. You can see arrows pointing down to 6 terms. There are 6 terms here. They are being separated by adding and subtracting signs. Subtraction, addition, addition, subtraction, and addition. So you can see those signs separate the terms. With those terms, there are 2 types. There are ones with letters, which are called variable terms. They are terms with a variable, and you can see 9x, 16x, and x are all variable terms. And then you can see that the leftovers are just numbers without variables, 2, 8, and 10. Those are called constant terms. These are terms without a variable. Now going back over to the variable terms, if you drop down one more, you can see what's called a coefficient. The coefficient is the number next to a variable. And what numbers are next to the variable x? It is a 9. So 9, we don't say 9x is the coefficient, we say that 9 is the coefficient to x. And we also say that 16 is the coefficient to x. And then we can also say x. Well, what's the coefficient there? It's the number right in front. Well, what is that number? It's not a 0, because 0 times x would be 0, and the x would not be there. It is a 1. Okay, so those are the terms. And now we need to know what a like term is. So like terms have the same variable. Okay, so 9x, 16x, and 1x are like terms. Or constants that can be added or subtracted together are also like terms. So let's learn how to identify terms in an expression. Here's the directions. Identify the terms, the like terms, the constants, and the coefficients in the expressions. All right, so let's go with A first. Remember, in an expression, terms are separated by adding and subtracting signs. Here we have an addition sign and a subtraction sign. So those are separating all the terms. There are 3 terms there. 8x, 2x, and 3. Are there any like terms in these? Yes, there are 2x terms. So we say 8x and 2x are like terms. Are there any constants in this expression? Yes, there is a 3. Are there any coefficients, any numbers in front of the variables? Yes, 8 and 2. All right, we got 4 more examples here before you get to do the you-dos down here. So we have a subtraction, subtraction, and addition. Here we have 4 terms. We have x, 12, 2x, and 22. Our like terms, our x terms are x and 2x. I'll change ink here. And our other set of like terms are 12 and 22. So there are 2 different sets of like terms. Our constants, of course, are 12 and 22. And our coefficients are the numbers in front of the variables. This x has no numbers, so we learned up above that it is a 1. So our coefficients are 1 and 2. On to the next. This one is a negative sign out in front, so don't bother with that one. Here's a plus sign, minus, and plus. So we have four terms again. Our four terms are negative 14b, 16, 18, and 3b. Our like terms are the b terms, negative 14b and 3b. And then we have another set of like terms, which are the constants, 16 and 18. Our constant terms are 16 and 18. And our coefficients, the numbers in front of the variables, are negative 14 and 3. For D, we have a plus sign, minus sign, and plus sign, separating the four terms. So we have 15a, a, 7a, and 9. Our like terms are the a terms. This time there's 3 of them. And 9 is a constant, and it doesn't have any other constants along with it, so it has no like terms. Constant terms would be 9. And our coefficients, there are 3 of them now, 15, 1, and 7. Where's that 1? That 1 is right in front of the a. Our last example before you try the you-dos, we have a plus sign, and plus sign. There are 4 terms again, negative 14, p, 5, and 2p. Our like terms, we have a p term and 2p, and then we have negative 14, there you go, negative 14 and 5. Our constants are 1 and 2. Oh, that's wrong. Erase that. Try it again. Our constant terms are negative 14 and 5. Much better. And our coefficients are 1 and 2. All right. Go ahead and pause the video and try F right now. Pause now. Okay, did you get them right? Check over each one, erase them if they're incorrect, and maybe even go back to the ones that we did together to relearn. If it's good, pause the video and try G now. All right, we're back with G. Boy, G was very different, wasn't it? We have a Y term here, and we have R terms over here that never showed up in the beginning. So what we're going to do is we're going to change this Y to an R. And then change this Y to an R. That's a mistake on my part in writing. Okay, so then we'll come down here, and there are now 3 like terms. There's negative R, 7R, and 2R. So if this was still a Y, Y did not have a like term. It didn't. There are no other Y's there, but R has 2 of them. I meant to have all R's there and not the Y, so that is my mistake, and now we have it fixed, and so we're going to move on here. Now I do want to come down here to the coefficients. There's a negative 1. Where does that negative 1 show up? Well, right in front of our new negative R, there is a 1 here. That's negative 1. It would have been right here. All right, so I'm looking over the next 3 of them. You're going to pause the video and do all 3 now. All right, we are back, and H, I, and J are done. You may want to pause video and take a look at your work and make sure that you have what I have here on the screen. So what we learned here is that expressions have pieces. Those pieces are called terms. Those terms are separated by addition and subtraction signs. We have a coefficients, and we learned what a like term is. Let's take a look now at what simplest form means. Now you've heard this a lot in elementary school. Here in 7th grade and on, it means an algebraic expression. Algebraic just says that there are variables now in math. An algebraic expression is in simplest form, if it has no like terms and no parentheses. Use the additive inverse to combine like terms. Write the new expression in ABC order with constants at the end. So we'll be practicing this as we go on to page 2. Error analysis. Now this is what's going to be on your test. You have a lot of these where someone does a problem and you got to find out what they did wrong. But before we begin, let's just review what we learned on the other side. To evaluate means to simplify. All right, we have some we do's here, and then we have a one you do. So in the first box, you're supposed to find out where is the error. Well, we learned that you can combine like terms. And we also learned that 9 is a constant and 5m is a variable term. And those are not compatible. And you can see whoever worked on this, they tried to do 9 minus 5 and got the 4 and just brought the m down. That is bad news right there. They're combining unlike terms. They cannot do that. It will not work. It is not true. And they tried to do it again on this side too, when they took the 6 plus the 7m, which are not compatible, and then they did 13m down here. Another bad move. Then, after they got there, they took these two, which would have been fine if they were correct, but they're not, and 4m plus 13m is 17m, but they made a big mistake back up here. So how do we simplify properly? Well, we want to be using the additive inverse like we had on the last page, and we only use additive inverse when we see subtraction signs. So then we use the additive inverse, and that's changing the subtraction sign into a positive and then doing the opposite to the number following it. And you can see here we have one subtraction sign, so we are going to use the additive inverse. Additive and the inverse of positive 5m is negative 5m. The reason why we do this is now that we have all plus signs, and that means you can add out of order. So let's put our m terms together. Negative 5 and 7m together, negative 5 plus 7 would be 2m's. And then 9 plus 6 is 15. And that's as far as we can go because 2m is a variable term and 15 is a constant, and they are not able to be combined. So this is your simplified answer. We've now evaluated it. Let's take a look at the next one. Where is the error? This one's listed differently. It's in steps. So we have a beginning of 3c minus 8 plus 14 minus c. And then they have an answer of 4c plus 22. So let's take a look. Remember, let's take our chances here, not our chances, but put things in our favor and use additive inverse on the subtraction signs. So additive inverse and additive inverse. Make those look like plus signs. All right, and we're going to put our like terms together. We know to do that. 3c together with negative c. Well, what's right in front of that c you can't see? A 1. So what is 3 plus negative 1? It is 2. Well, we have a problem here. They think that 3c minus c is 4c's, and it is not. Did they make any other mistakes? Well, here they have negative 8 and they have 14, and in a t-chart, we put our 14s on here and our negatives here. We move it across and you can see it's a 6. So that's wrong too. It's not 22. So they made a mistake, made a big mess here. They made a mistake in combining their terms. They knew that they needed to combine them. Get rid of this here. Hold on. They knew they needed to combine the like terms, 3c and minus c, but 3c's take away 1c right here, or you could use additive inverse, would have been 2c's, and that was the problem. They also saw this one here, negative 8 or minus 8 plus 14 at additive inverse would have given them 6, and that's a big problem there too. So let's go down here and do it correctly. It's always important to go to your subtraction signs and do additive inverse to them first. Then you can add out of order. Let's put our like terms together. They go in the front. 3c plus negative 1c, remember there's a 1 here, is 2c's. And then negative 8 plus 14 is 6. And that is as far as we can go. You cannot combine those because they are not like terms. All right, pause the video and find the mistakes, and then try it on your own. Pause now. All right, I looked at it. Hopefully you found the same thing. I saw some subtraction signs, so I did the additive inverse to both of them. And I know we have to add the k terms together. Negative 5 plus 6 is definitely not 11. And negative 9 plus negative 7 is definitely not negative 2. So those are two wrong moves, but what I saw was super wrong was that they took a k term and a constant and they tried to combine them together to get 9k. That is really bad. You cannot combine unlike terms. So then, after finding those things that were wrong, I came to the subtraction signs here and did additive inverse and additive inverse. I'm going to put my k terms together. Negative 5k and 6k is 1k. And negative 9 plus negative 7 is negative 16. Okay, so this is the answer, but there's a better way to write it. We don't need the 1 in front of the k because 1 times k is just k. We can also do with less signs here. This is adding a negative. That's the same thing as subtracting a positive. So if you had this answer or this answer, this one is the best. That's superior. This would be the second best. And this one would have been the third best. They're all correct, but this one is the best of the best. All right, let's do some together, and then you're going to do them here at the end. Directions: write each expression in simplest form. So we'll start with k, and we can see we have two terms here, and these two terms are separated by an addition sign. They have the same variables, so we can combine them. They are like terms. That is 8x. I. Oh, sorry, that's an L. All right, I'm going to use additive inverse on this. They are the same variables, so they can be combined. 4n plus negative 6n. I have more negatives than I have positives. I have two more, so it's negative 2n. This one I'll use additive inverse down here, and I know there's a 1 in front of this c. So they're all c's, so I can combine them all. 2c and 4c is 6c's. And 6 plus negative 1c's is 5c's. I see a subtraction sign here. I'm going to do additive inverse, and then I'm set to go. Everything's being separated by addition signs now, and I can put my a terms together. 3a plus negative 4a is negative 1a, and then I can put my constants together. 5 plus negative 2 is 3, and do not combine those. But there is a better way to write this one. This could be written as negative a plus 3. That would be pro level right there. Then O, we're going to go additive inverse, put our like terms together. 7n and negative 2n is 5n's. And then we'll put our constants together. 1 and negative 1 is 0. So our answer is 5n. These ones have all plus signs already, so we're going to put our y terms together. 12y and negative 5y. We have more positives than we have negatives, and so that's going to be 7y's. And 2 plus 5 is 7. And that is it. Can't combine them because they are not like terms. Here we have a bunch of 5's going across, but we did spot a negative, sorry, not a negative, a subtraction sign right here. So we're the additive inverse to it. And now we have all of addition signs. Addition, addition, and addition. So let's put our a's together. 5a plus negative 5a would be 0a, actually. And negative 5 constant plus 5 would be 0. All right, let's clean this up. What is 0 times any number? It is 0, so the a would be gone. And this is gone, so the answer here is 0. That's it. R, additive inverse. Negative 10r is by itself. And 13 plus negative 13 is 0, so the answer is negative 10r. The last one, the absolute value bars show up again. Those are grouping symbols, so we're going to be paying attention to gems, and we'll do the grouping symbols first. The absolute value of negative 12 and the absolute value of negative 12. Well, this one is 12, and this one is 12. We bring down all the signs we didn't use, this minus sign, the 8s, and the plus. We will do additive inverse to the subtraction sign, and 12 plus negative 12 is 0, and 8s comes down. All right, it is your turn to pause the video and try these out. We have this colossal problem down here on Z. Just be careful, do what you've learned, and I'm sure you'll be fine. Pause now. Okay, you can see all of them. Take a look at them real closely. If you have mistakes, try and find out what you did, find your errors, and then correct them. Down here on Z, I do want to note that there are so many terms that I had to use t-charts to stay organized. I had a Z t-chart, and then I had a constant t-chart on the right. And so after I used the additive inverse all the way through, well, first I did the changing my absolute value into 9Z right here. Then I brought everything down, and then I used the additive inverse on every subtraction sign I could see. And then I put all the Z coefficients into the Z coefficient t-chart, and then I put all of the constants into the constant t-chart. And there are two answers here. This is a good answer, 5z plus negative 2, but adding negatives is the same thing as subtracting positives. This one's better because it has less signs and it means the same.